This is Hugh Dunstan,
And Tim Roberts.
and we are here today to continue our journey of discovering the exciting new insights around using high-demand amino acids, or HDAA.
So let's start, Hugh. Can you give us an idea about the role of high-demand amino acids in hydration?
So everybody knows when we sweat, we're losing fluid and electrolytes. And indeed, there have been many research papers and advisory papers brought out how you should replace both fluid and electrolytes to recover from exercise. Recently, though, our research has shown that when you're sweating, you're also losing large amounts of amino acids.
Hugh, when you say research, I know what you were doing down there in the laboratory, but perhaps describe that a little bit. What sort of research is all of this data based on?
It was quite fun, actually. We had to work out ways of collecting sweat. So we had a lot of athletes doing prescribed exercise routines in controlled climates. We collected the sweat, we analysed it, and we looked at the materials that were in the sweat, so what kind of molecules are being released in there, and we also looked at the electrolyte composition.
So the data that you've collected is statistically valuable and solid, and as a result of that, certain amino acids were released in greater numbers in sweat.
Yes, so the reason we looked at this is that we've been looking at people with long-term illnesses and net losses of nutrients, and we were wondering what the process was associated with sweating. Now, it's been known for decades that people lose amino acids when they're sweating, but nobody's really looked at how this relates to the body's capacity to supply these resources. And they haven't looked at it in terms of, well, if you lose the amino acids, do we actually need to be looking at replacing them? So we set out to look at the nature of sweat losses in groups of athletes in defined conditions. And one of the problems that had always made it difficult for this research is a very high variability. So in other words, lots of people varied hugely with what they put out in sweat. And we were the first group to actually show that you could have different types of sweaters in the population. You have people that produce relatively low volumes of fluid, and those that produce high volumes of fluid, and those in between. And they all have characteristic compositions of amino acids and electrolytes. So it's hard to just generalize totally. But because we were able to do that, we could, for the first time, actually effectively quantify the losses of amino acids, the losses of electrolytes, and relate that back to what's available in the circulatory system in the body.
Yeah, so looking at that in more detail, when you looked at the amino acids loss, that's where the laboratory data showed us that there were 6 amino acids lost in far greater amounts when you're looking at urine, when you're looking at the sweat. And these 6 amino acids don't only have roles in building proteins, but they've got other important roles in the body. So if then logically there becomes a deficit of amino acids during the day, is that going to mean less function, and how do they get replaced?
Yeah, so these 6 amino acids are known as functional amino acids. So not only, as you said, Tim, are they involved in making proteins, but they also have critical value in making the body work. So for example, one of the amino acids, glycine, is used to build what we call a porphyrin ring, or the key structure that is at the heart of hemoglobin. So this is the This is the molecule that enables you to transport oxygen around the body. So if you don't have enough of this amino acid, then long term, it can affect your capacity to produce hemoglobin and therefore limit your energy supplies. Also, the same porphyrin ring is used in the processes of extracting energy. And this occurs where they're incorporated into what we call cytochromes. And this is really the very efficient energy extraction system that the body uses to generate energy from sugars and other nutrients that you take in. So these high demand amino acids have very fundamental roles in your body's energy systems and enabling you to perform properly. They're also utilised in the construction of hormones. They're used in the formation of neurotransmitters. And there's a huge array of these functional roles that are utilised.
Wow, that was a long answer. But importantly, I think it's saying that for the people with chronic conditions like chronic fatigue syndrome, and for the athlete or the normal person who's working in an environment where they are sweating a lot, there could be a deficit of these very important amino acids. And so I guess the body has to find a way of replacing them, or we have to get them as a supplement.
That's right. So there's a couple of points to that. Firstly, I think people probably generally don't realise how much fluid we lose when we're exercising or during a work day. To give you some idea, it's very reasonable to lose 500 mils to 2 litres during reasonable exercise. If you're doing very extensive exercise or endurance exercise, you can be losing 2 to 4 litres per hour. If you're a manual labourer working in a hot environment, you can lose up to 14 litres a day.
Wow.
And if you're just working in moderate conditions, you can lose 4 to 5 litres a day. So this represents very significant losses of fluid, electrolyte, and the HDAA. Now you mentioned how can we regenerate supplies of these. Some of the HDAA are what we call essential amino acids, so they have to be taken in the diet. Others can be made by the body, but under conditions of exercise or working where you're continuously losing these amino acids, the body can't keep up with demand. And there are a couple of reasons why this occurs for some specific HDAA. There is a real limit to the rate of their manufacture in the body. So it's very important that we can actually replenish these. Now, a lot of people will say, okay, just eat more protein. That's fine. A lot of people find it hard to eat enough protein to properly replenish these, especially if you are doing a lot of activity. But the other aspect is that the other 14 protein amino acids that you'd be taking in aren't needed in the same quantities. So what happens when you take in excess amino acids? Well, a lot of them get converted to fats, and that's why people sometimes have problems. They're doing lots of exercise, they're eating well, but to compensate, they're eating a lot of protein. And so this is an extra add-on, if you like, to the fat stores. Otherwise, they'll be processed for energy and utilised in some other way by the body.
Yeah. I think that the other area that I particularly like to read about, and our research in that area, in the area of the catabolic state, where we have individuals with chronic conditions, and that was some of our earlier research. These individuals are not in an anabolic state where they, such as they are able to eat protein, break it down, get the amino acids. in the catabolic state, that digestion isn't working so well, and so there's a breakdown of muscle proteins. The muscles are the reserve bank of amino acids, if you like. And if you're exercising, you're also in a catabolic state. So if you are in a state where you need the high demand amino acids, your body will go to the muscles if they're not available by mouth. What do you think on that statement, Hugh?
That's absolutely right. And so that means when you've done your exercise or long periods of labour, that means that part of the recovery process is to actually rebuild and replenish the muscle proteins that you've broken down. So this affects your recovery times. And if you can actually minimise the amount of catabolism or breakdown of muscle proteins by taking HDAA as you're exercising or as you're doing your endurance activity or as you're working, then you're reducing the amount of muscle wastage or muscle protein breakdown, and therefore it makes recovery a much more efficient process.
Hugh, before we finish, and we must finish in a minute, could you just summarise then what is the best form of hydration based on the research that you and based on our research? What is the best form of hydration? What do you need in that bottle?
So you need to replenish the fluid, you need to replenish the electrolytes, and you need to replenish the HDAA. So it's really important to keep track of how much fluid you're losing during your exercise or during your endurance sport or during your work day. If you can aim to replenish those fluid quantities and take in appropriate quantities of electrolytes and HDAA, then that is the key to optimizing your performance and improving your capacity for recovery.
Well, dear listeners, thanks for joining us today. I think the take-home message then is that for the best hydration, we need to have liquid, we need to have electrolytes, and we need to have the 6 high-demand amino acids. As the summary of what we've been talking about.
So if you want to learn more about HDAA, you can do so by typing HDAA nutrients into your search engine. And remember, HDAA for active humans.